Welcome back. In this video we will discuss the next question, that is design an algorithm for checking whether all elements in a given array are distinct or not, and we have to derive its worst time complexity. What is the meaning of distinct or not? So for example, I am having 10 elements in an array. Whether all elements are different or same, we have to find that. That's it. So we have to design an algorithm for this. So how to design? We will see. So for example, I will take one small example to show how to write an algorithm for this. Just I will consider an array. I will consider one array having some elements. For example, 1, 2, 3, 4, 5 elements we are having from 0 to 4. So now what I should do? All these 5 elements are distinct? Yes, these elements are not same. So if it is there, we have to return the value as true, your answer. If any elements is same, for example third element is also 10, first element also 10, then that is not distinct, so you have to return false for that. So we will check how to do this. So simple logic here. First I will check this element with all remaining elements. Next time I will check second element with the remaining elements. Okay. Next time third element with the remaining element, and fourth element with remaining element, like this. So how many times we are comparing? From 0 to 3. What is the meaning of 3? For example, how many elements? 5 elements, so n is equals to 5. So this is n minus 1, this is n minus 2. So that means we are doing number of repetitions. How many times? From 0 to n minus 2. So I will take I from 0 to n minus 2. So I will write same thing here, a loop by using for loop. For I is from 0 to n minus 2, I will do some steps. Okay. Next time, when I is equals to 0, 10 is comparing with which element? 20, 30, 40, 50. So again comparison require one more for loop for comparing all elements again and again. So which element I will compare with 10? 20. 20 is present at first. So is first pointed by any location? Any variable? No. So I will take one more variable j. So that means I will use one more for loop for j is equals to 1. 1 means, can I write 0 plus 1? That is 0 present in I. So can I write j is equals to I plus 1? Yes. 2. How many times? So until 50. 50 present in 4. 4 means n minus 1. So this loop repeats from I equal to I, j is equals to I plus 1 to n minus 1. Outer for loop repeats I equal to 0 to n minus 2. Video is not clear. 1 minute. Okay, now? Yes, fine. So what I will do, I am going to compare. Compare means I should use if. What I will compare? I with j. What is the value of I? 0. A of 0 is 10. What is the value of j? 1. 0 plus 1, 1. So a of 1 value is 20. So 10 is equals to 20? No. If it is no, we have to return true. Again loop repeats, I goes to 2, I is incremented by 1, I goes to 2, again 30 is compared with 10, no. Next 40 is compared with 10, again no. 50 compared with 10, no. For example, here in the third location, if the value is 10 itself, that means here 10 is equals to 10, yes. If it is yes, we should return false, that is elements are not distinct. Else, after completion of all two for loops, I mean up to last element, so no element is same, so we should return true. That's it. So this is the algorithm. So how to write algorithm? Just write using the keyword algorithm followed by space followed by name of the algorithm. So name of the algorithm, for example, find distinct, so I will give name as distinct itself, open parenthesis, and I will pass array from 0 to n minus 1 value, and I will pass the value n. Next, open this algorithm and you can close this algorithm like a pseudocode. Yes, so this is the algorithm to find whether all elements are distinct or not. So for this algorithm we have to find worst case time complexity. So we can easily find worst case time complexity just by using, so in the last videos I told how to find time complexities, same way. So here also, so that is not big deal. So here this for loop, how many times it will repeat? This for loop from 0 to n minus 2. So that means 0 to n means, so n minus 2 times it will repeat if the condition is true, and one more time if the condition is false. Next, this loop repeats from I plus 1 to n minus 1. So that means n minus 1 time it will repeat. So if 1 or 2 points are less, no problem, and 1 time if it is false. Next, it will repeat n and n. This line is related to these two for loops. So that means n into n, that is n square times it will repeat, and it will also repeat. So this is this related to this execute n square, then this will also execute n square times, and finally return false, it will execute one time. So finally just check it, n square, just add all those time complexity of each line. So n square plus n square, 2n square plus n minus 2 plus 1, that is n minus 1, 1 cancel, so n minus 1, that is 2n minus 1 plus 1 cancel, so that's it. So 2n square plus 2n. So in this, so which one is the highest order, n or n square? N square. So time complexity will be worst case big O, in the order of big O of n square. That's it. So this is very simple, and they depends on the marks, so you have to calculate as per mathematically. So I will show this worst case time complexity how we can derive by using mathematically. They asked to derive, so we have to derive by using mathematical expressions. So mathematically we can derive worst complexity as follows. So just I will say now how to derive this time complexity by using mathematical notations. So can you people tell me what I am doing here? Comparison. Comparison is related to how many loops? 1 and 2. comparison is depends on two for loops. What are those two for loops? One is inner for loop. Inner for loop. So inner for loop from I plus 1 to n minus 1. So can I write inner for loop as summation of j is equals to I plus 1 to n minus 1? Yes. So this will repeat number of times like this. Next, outer for loop. So what is the outer for loop? Summation of I is equals to 0 to how many times? N minus 2 times, like this. So I will combine these two. Now see here. So how to write that? Summation of I is equals to 0 to n minus 2, summation of j is equals to I plus 1 to n minus 1, and after these two for loops, what I will return? Either true or false. That is one time I will repeat. So I will write 1. That's it. So this I can rewrite. So this one I can write by using the formula. We know the formula already. That is summation of I is equals to k to n 1. Then I can write upper limit minus lower limit plus the value 1. So here also I can write I equal to 0 to n minus 2. Just I am removing summations so to get final value. So can I write upper limit minus lower limit plus 1? Yes, I can write. So here minus 1 plus 1 gets cancelled. So finally I will get I is equals to 0 to n minus 2, n minus 1 minus I. Yes, I can write like this. So now tell me, so can I write these n minus 1, one summation minus I to another summation? Just I am dividing. I is equals to 0 to n minus 2, n minus 1 minus summation I is equals to 0 to n minus 2 I. Yes, I can write. So now just I will write remaining part here. Okay, what I got previously, summation I is equals to 0 to n minus 2, n minus 1 minus summation I is equals to 0 to n minus 2 I. So now is it visible? Yes. Now can I write, we know one more formula, summation from I is equals to 1 to n I. I can write n into n plus 1 divided by 2. So apply these for this. Now what it will become? I is equals to 0 to n minus 2, n minus 1 minus, so n means n minus 2 into n minus 2 plus 1, that is n minus 1 divided by 2. Yes, I can write. So now just write this by using this formula, upper limit minus lower limit plus this upper limit minus lower limit is 0. Sorry, don't use now. So n minus 1 take outside. We don't have formula for this. So I is equals to 0 to n minus 2 1. If you take outside, here it will come 1. So one more step is there to use this. So now I can use this. So n minus 1 common. So upper limit minus lower limit plus 1. So what it will become? N minus 2 minus 0 plus 1. So minus n minus 2 n minus 1 divided by 2. So now minus 2 plus 1 minus 1, n minus 1 n minus 1, n minus 1 into n minus 1 minus n minus 2 n minus 1 divided by 2. So if you want, you can just divide this, multiply this. N into n square minus n square plus 1 minus n into n square minus 2n minus n minus 2 divided by 2. Okay, now so just take the LCM for these two. So 2n square minus 2n minus 2n square plus 1 minus n square minus 2n minus n minus 2. So just if anything, so 2n square gets cancelled, 2n gets cancelled. So now remaining what are the remaining? Minus n square minus n minus n square minus n minus 2 plus 1 minus 1 divided by 2. Okay, now tell me, in this hence by using above efficiency will be, so what is the highest order here we are having, n or n square? N square. So just in terms of big O of n square. So that's derived the efficiency for the algorithm. Thank you.